right, everybody, welcome to Earth Science. Let's figure out how to analyze this lab. And volume up. I know some of you do it on mute. No mute. Got to hear this, all right? Especially the first minute or so. Let me get through the really important part. After that, if you say, I'm going to figure this out on my own, fine. I'm going to still do the video to give you all the pointers on all the pages, but the really important part here is the beginning. So this is your setup. You guys tested those things. Now, this lab, I discussed this with a few of you today as you did this. There's a lot of sources of error in this lab. The size of the tube is not big enough to really truly test this. The tubes were wet, already once you did your second and third trials. How carefully did you open it, and did you lose any water here or there? There's a lot of places where this can go a little bit wrong. So I don't get too uptight about the results in this lab. It's more about understanding what these three things are. That said, the first thing I want to do here is scroll way down to whatever page this is, page 6, and answer this stuff. That's too big. It's how it should work. Now, these are going to be your results. You're going to tell me what your relationship was, even if it's wrong. I want you to do it by your data. But here's how it should work. So for the different particle sizes, permeability, that's like the speed, the rate at which water goes through. As particle size increases, just a better color going here. Maybe not. Permeability does what? So as you get to bigger and bigger particles, what happens to permeability? Well, the spaces get bigger, so the water can get through there a lot faster. So if we say there's larger particles, we're going to have a larger permeability as well. Permeability. The water goes through is faster. Capillarity, as particle size increases. This one, and a lot of people had good ideas with this. As particle size increases, what should happen to the amount of water that gets stuck to the particles? Well, there's more available surface with the small ones. There's more spots where the water can get stuck to, get detached to. So as particle size increases and actually those spaces get bigger, the capillarity, decreases. Again, that's how it should work in real life. Your numbers may not reflect that. It's very hard to get the slide to work. It's just the design of it's not good enough. And our equipment's not good enough. Porosity, this is the interesting one. Porosity is how much of this is pore space. So what happens here as particle size increases? Well, I think about this as how much of this diagram is the space between the beads. If I were able to color it and say that, and then figure it out as a percentage. What percentage of this image is taken up by those? Here's the deal. In fact, we can do this with the little zoom thing here. This kind of shows it. If I make this way bigger, do I change the porosity? I just made the beads bigger magically with the zoom function, but the ratio of space to bead stayed the same. If I make them very small, they're small beads. Now the ratio of the space to the beads stays the same. It's a weird function, but what happens as particle size increases, porosity stays the same. Now, this all counts for rounded, sorted particles only. Porosity would stay the same, the capillarity will go down, and the permeability will go up. It's weird, right? But think about it this way, too. This one has bigger spaces, but there's less of them. This one has smaller spaces, but there's more of them. So it adds up to roughly the same amount. It's like saying 4 quarters or 10 dimes or 100 pennies. It all works out to be the same, right? Your porosity should stay the same. All right, that part we got to have. Now I'm going to go through and do page by page, and I'll timestamp all of this, right? To say, what do you want to get up in this lab? And I know some of you are going to go harder on this than others, but what are you going to do? I appreciate it. All right, just give me definitions up here. You got those right in your Marble notebook. This stuff, it's all already in your Marble notebook. This is like done for you. You can do these in like 2 steps. And remember, well, note what I did here is there's a page for porosity, then there's a page for permeability, then there's a page for capillarity. So don't try to sketch out everything you did in the first one. The porosity, what you did was you filled the empty space with water and measured how much water it was. Done. And then permeability, drained it and timed it and saw how tall the water column was. And 3, capillarity, when we took the water out, we saw how much didn't come out, how much was stuck to the beads. So your procedure can really just be quick steps like that. Don't skip it, but don't get panicked about, oh man, I got to write a book here. The numbers you got, as I walked around today, people were getting all this stuff. So this should be sitting right in your Marble notebook. Sketch the graph. What does it approximately look like? Did the numbers look like they went up, up, up? Did the numbers look like they went down, down, down? I'm not saying like plot, but what does it look like happened as we went through these 3 numbers? Did they go up? Did they go down? Did they stay the same? And some of us, again, because I know that data, like in this lab, as I've said a couple times now, doesn't always work perfectly. Maybe it went up, then down, because things just aren't working out right. And again, I'm not saying that that's right in terms of like how it really should work, but that's going to be as close as we can do with our limited equipment. What else? Graphs. And I popped open somebody's lab from last year just to say, here's all it's going to be. So don't see these graphs and start to panic. 3 points, boom, 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 connect the 3 dots. That's what I want to look. But I want accuracy. Use your numbers and accurately plot those 3 points. They're all pre-labeled. Everything's good to go and ready. The particle sizes, yep, they're on there, 4, 7, and 12. Even if it might be 8, we'll call it 7. So dot, 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 and connect them. Right? That should do all of that. Couple of questions. What were your results? That we just did. And then down here, this reading right here will say, it'll tell you about something that it will say color that this. So I'm going to be able to tell very quickly if you didn't read that, because when you read it, it will say things like color something, color that with a light blue pencil. Just use light blue in Cami and you'll be good. All right. What do you think? Doable. That's a double lab. And again, done with our heavy data labs. You'll do great. All right. I appreciate everybody. Take care.